Electric refrigerator. Scientists just built a refrigerator with no compressor. And no refrigerant gas. Just electricity. Using a multi-layer ceramic capacitor. Researchers created a solid-state cooling system that changes temperature when an electric field is applied. The result: 4.5 K cooling swings. Works across room temperature. Survives 10 million cycles. No moving parts. Projected 70–90% Carnot efficiency. This is electrocaloric cooling. And it may become one of the biggest threats to conventional refrigeration in decades. Older materials only worked above room temperature, and needed a brutal 42-day annealing process. This new PSD-PMW material cools down to 230 K, avoids the expensive anneal, handles massive electric fields, maintains strong entropy transitions. The physics is beautiful. An electric field reorganizes the material's internal dipole structure, reshaping entropy inside the lattice, and producing a real temperature drop. Not cold generation. Controlled entropy engineering. If this scales. Silent refrigerators. Ultra-efficient chip cooling. Vibration-free scientific systems. Wearable thermal control. Next-gen EV cooling. We may be watching refrigeration evolve from mechanical compression to programmable matter. Excerpt from the New Physics. He post highlights a May 2026 Nature paper on PSD-PMW multi-layer ceramic capacitors achieving 3 to 4.5 K electrocaloric cooling swings near and below room temperature via electric field-driven dipole reordering and entropy changes with no moving parts or refrigerants. Improvements over prior PSD materials include skipping the 42-day annealing process, lower sintering temperatures, strong performance down to 230 K, and durability exceeding 10 million cycles at high electric fields. Replies note it's an incremental advance in caloric cooling, rather than an immediate full replacement for compressors. Please refer to this.